So good evening, Aditi.
Good evening, sir.
Have you tried yesterday questions? Yesterday we discussed about the RS nomenclature, na? RS.
Yes, sir.
Okay. So that you had practiced. Along that one, I taught some DL system also. Is it right?
Yeah, sir.
Okay. So have you gone through that image, this one, and some examples they had given?
Yeah, sir, I did go.
Okay, then fine. So okay, Aditi. So today we will discuss about the conformational isomerism. Okay, so conformational isomerism also it comes under the stereoisomerism. Okay, actually, stereoisomerism is classified into how many types? Two types. So one is the conformational isomerism, and another one is configurational isomerism. Okay, so under the configurational isomerism, we studied about the geometrical isomerism and optical isomerism. Okay, so geometrical isomerism, how many types of the geometrical isomerism it is there? Everything we studied. Okay, and while coming to the second concept, optical isomerism. Optical isomerism also we completed. Okay, the next concept we are having is here conformational isomerism. Okay, so conformational isomerism. Actually, what is mean by the conformational isomerism? Okay, which compounds are they exhibit as a conformational isomerism? Okay, in this one, the first one is conformational isomerism are exhibited by the alkanes. So which are exhibited as a conformational isomerism means here alkanes are exhibit as a conformational isomerism. Alkanes are they exhibit conformational isomerism. Why the alkanes only they exhibit as a conformational isomerism means here because of carbon-carbon free rotation it is that carbon-carbon free rotation. Okay, so carbon-carbon in alkanes what happened here? Carbon-carbon in between we have a single bond or double bond in alkanes. Aditi, in alkanes, so carbon-carbon we have a single bond or double bond?
Sir, in alkanes will have single bond.
Alkanes we have a single bond. Okay, so whenever carbon-carbon single bond it is there means so we can easily rotate now. We can easily rotate. Let us see, let's consider this is the one sigma bond, this is the one carbon atom, and this is the one more carbon atom. So these two are connected with the sigma bond. Okay, so whatever the middle it is there, that you can consider it as a sigma bond. Now, if I keep like this feature, is any possibility is there to shoot the one carbon behind another carbon atom it is there? If any possibility is there to shoot the to see the two carbon atoms at a time?
No, sir. If it's at the same angle, no. But if it's a different angle, we can see.
Very good one. Okay, if the slightly if I change this like this means now we can change, we can see. We can observe that two carbon atoms. Is it right? Okay.
Yes,
Otherwise, if I keep this one means it is not possible to see the two carbon atoms at a time. Okay. So when in this one we are keeping one carbon is the constant. We are rotating the another carbon atom. If I am keeping one carbon is the constant, and when the second carbon atom if I rotate some 60 degrees, we got as some different structure, huh? We got some different structure or what? Okay, again, if I rotate some more 60 degrees, we got as some different structure. Like that, every 60 degrees, if you're rotating means we got as some new structure. Okay, that new structures are we can call as a conformers. And the phenomenon is called as a conformational isomerism. Okay, and the phenomenon is called as a conformational isomerism. Okay, actually if you want understand means then we can represent with some video. I want to show some video. Okay, now I'm going to share the video. and I'll share some video. Right. So all of you got the screen, ma? Aditi, you got the screen?
Yes, sir.
Yes, sir.
Samhita. Okay. Right. Now here onwards, I'm going to play the video here. Now let us see. So actually, this is the alkene they had taken as a ethane. Okay, it is a three-dimensional structure. Three-dimensional structures cannot be represented on the plane of the paper. Okay, if you want in this one means if you observe, so two carbon atoms. First, we can consider it as a okay. First one, fourth one. Now let us see this one. So blue color we are considering it is what are the two black carbons are there? If you observe in this one means here two black color it will be there. Black color or we are considering it as a carbon. Okay, so carbon is surrounded by how many bonds? Carbon is attached with the how many bonds, ma? Carbon is attached with the 4 bonds now. Okay, now in this one is attaches with one carbon is attaches with the neighboring carbon, and the remaining carbon is attaches with the 3 different atoms. That means if you take ethane, means each carbon is attaches with the 3 hydrogen atoms. Is that clear? Okay, now let's see. If you take all or white color means definitely we can get as a little bit confusion. To overcome your confusion, they had taken one is the blue color, remaining 2 hydrogens are they represent as a white color. Okay, now let us see how they are going to be rotated. Okay, so now one is behind another one. They rotated 60 degrees. If they rotated 60 degrees means you got as a one structure. It is different or not while comparing with the first one. Okay, it is different or not, ma? You got some different structure now. By rotating some 60 degrees, you are getting some different structure. Again, if they rotate one more 60 degrees, let us see. If they are going to be rotate one more 60 degrees means this blue color, it comes to here. Okay, exactly opposite to the white color. Okay, now he is going to rotate. If it is rotate one more 60 degrees means this blue color, it comes this side. Now again he is rotating some 60 degrees. Now let's see. Again after rotating one more 60 degrees, you got one more structure now. Okay. So again you got as a one more structure. Again, if they rotate one more 60 degrees means again you'll get as a one more new structure. Okay. Is rotating one more new structure. Now let's see. After rotating one more, sorry. Let us see, ma. If you rotate one more 60 degrees, means two blue colors are exactly present in opposite direction or say same direction. They present exactly opposite, na? Okay, so they present exactly opposite. So whenever they're rotating by the 60 degrees means we are getting as a new structures. All that new structures are we can call as a conformers. So that is also we can represent on the plane of the paper. Actually, if you write, if I show something means if you won't understand, that's why I showed that video. Okay, now simply we can see. Actually, how we are going to represent the conformational isomerism means here. Conformational isomerism can be explained based on okay Sahar's formula and Newman projection formula. Okay, conformational isomerism can be explained based on Sahar's formula. Okay, so conformational isomerism can be represented with here Sahar's formula. Okay, and Newman projection formula. Newman projection formula. Okay, Newman projection formula. Is that clear? So Sir, what is meant by the Sahar's formula and Newman projection formula means here? So these two also used to represent the organic compounds. Actually, organic compounds can be represented in different types. I think so. You must studied some different concepts also. Organic compounds can be represented with a complete representation, condensation representation, line representation, and three-dimensional representation. So like that, so Sahar's formula and Newman projection formula also we are writing. Okay, sir, what is meant by the Sahar's formula? What is meant by Sahar's? Okay, Sahar's. What is meant by the Sahar's means here, sir, whatever the structure it is there, so it look like as a some horse type. Okay, so nowadays, so something we are using to play the children at home also. If small kids are there, means yeah, somebody they are purchasing the wooden horse. So which one is swings front and back like this? Have you seen or not? Okay, some kids are there playing now. They may be made up with the plastics or something. Okay, now let's say I will give one example here. So I'm taking as a ethane. What is the molecular formula of the ethane? Samhita, what is the molecular formula of the ethane? Samhita, Sai, Akshit, Sirisha. Okay. So what is the molecular formula of the ethane, ma? Sirisha. Sir, molecular formula of the ethane is C2H6. This also we can write as CH3 bond CH3. Okay. Now in this one, first I'm writing as a like this here. Okay. So this corner represents as a one carbon atom. So this is the one corner. It represents as a one carbon atom. So this is the another carbon atom. This is the one carbon atom, and this one is the another carbon atom. Okay, each carbon atom is attaches with the three hydrogens. Okay, so this one. So let's see, this carbon is attaches with the three hydrogens, H, H, H. Okay, and another one is attaches with the three hydrogen atoms, H, H, H. Sir, actually you are able to see. Okay, if I'll keep like this means, is any possibility is to see these two carbon atoms? So let's say this is the one carbon atom and this is the one more carbon atom. If I'll keep like this means, is any possibility is that two carbon atoms at a time? It is not possible now. So that's why slightly I change the direction. If you slightly change the direction means you can observe two carbon atoms are attached with the one bond. Okay. Now each carbon is attached with the three hydrogen atom. Whenever you see means here, it look like as a horse model here. So that's why we are calling as a sawhorse. Okay. So whatever the shape we wrote, that we can call as a eclipsed formation. That we can write as here eclipsed formation. So when we can call as eclipsed formation means is when one atom is exactly behind to the other atom. One atom is exactly behind to the another atom. Then only we can call as a eclipsed form. Okay, so which we can call as eclipsed form means here when one atom is behind another atom which cannot be seen, which we cannot see, that we can call as a eclipsed form. Okay, so this we can call as a eclipsed form, and this also we can write one more. Okay, so what is another one means here we can write in this one carbon atom I'm keeping as a constant. One carbon atom I'm keeping as a constant. First one I'm keeping as a constant. Okay, so first one a carbon is attached with the three hydrogens, H, H, H. And so this one I'm totally rotating 180 degrees. If I rotate 180 degrees means you will get this kind of structure. The first hydrogen is exactly present opposite direction. When the first hydrogen is exactly present in opposite direction means that we can call as a staggered formation. That we can call as here staggered formation. Okay, sir, first these two structures we can write as a Newman projection formula also. Okay, these two are we can represent with Newman projection also. Okay, Newman projection formula. Newman projection formula. So what is meant by the Newman projection formula means here? So two carbon atoms. Now here we have taken as a two carbon atoms. In this one, two carbon atoms. First one carbon atom is we can represent with the dot symbol. In this one carbon atom is represents with the dot symbol. Okay, and this we can consider as the first carbon atom. First carbon atom is attaches with the three hydrogens. First carbon atom is attaches with the three hydrogens. They present in a trigonal planar manner. In between two hydrogens bond angle it has to be 120 degrees. How much bond angle it has to be there means here 120 degrees has to be there in between the two hydrogen atoms. Okay, and second carbon atom we are represent with the spherical symbol. Okay, so we can write like this here. Second carbon atom we can represent like this. Okay, second carbon atom also it is attaches with the three hydrogen atoms only, na? That we can write as a H, and here also we can write as a H, and here also attaches with the H. So exactly this means three dimensional means exactly this hydrogen are exactly they present one behind another one. Okay, actually if you write three dimensional, is any possibility is there to represent the three dimensional structures on the plane of the paper? Samhita, is any possibility is there to represent the three dimensional structures on the plane of the paper?
No, sir, not really.
It is not possible, Mahia. So that's why we are representing with the Newman projection formula. Okay, so exactly opposite means that we can call as eclipsed form. Na? This we can call as a eclipsed form. This we can call as a eclipsed form. And let us see in this one, two hydrogens are present exactly in opposite direction. That we can write like this. Okay, this is the second carbon atom. First carbon atom I'm writing like this here. First carbon atom I'm keeping as a constant. I'm not disturbing the first carbon atom. Here H, here H, here H it is there. Second carbon atom by rotating, okay, exactly 180 degrees means the hydrogen is present at exactly opposite direction. Okay, so this is the first carbon atom, this is the second carbon atom. First one we are keeping the constant, second one we are going to be rotated. When you rotate 180 degrees means whatever the structure it is formed, that we can call as a staggered formation. Okay, so based on this one, they're asking the NEET level questions now. Okay, sir, what are the questions they're asking means here? They're asking the stability order. Okay, I didn't write the all confirmations. Just I wrote as a just two only. Okay, to explain the Sawhorse and Newman projection formula, I wrote the structures. Okay, if you want a clarity means now I'm going to take one more example to explain all confirmations. Okay, I'm taking one more example to give all confirmation. What is the another example I'm taking means here? Sir, butane. Okay, so by taking up the butane, I will explain all other conformational. Okay, all other conformers. Okay, here I'm taking as a one example is butane. Butane and butane ma. I can write as a butane like this na. CH3 bond, CH2 bond, CH2 bond, CH3. So this we can call as a N-butane. That we can call as a N-butane. In this one, I am taking as a second and third carbon atom. Second and third carbon atom. First I am writing as a Sawhorse representation. Okay, this is the second carbon atom and third carbon atom. If you observe the second carbon atom is attaches with the one methyl group and two hydrogens. Second carbon atom is attaches with the how many methyl groups and how many hydrogens? Ma? It is attaches with one methyl group and two hydrogens. Hence I can write like this: CH3 bond H bond H. Okay, and second carbon atom also it is attaches with one methyl group, two hydrogens. CH3 bond H bond H. Okay, so this we can call as a eclipsed form. Okay, this we can call as a eclipsed form. Okay, now so one by rotating every 60 degrees we are getting at some different structures. I'm writing all that structures. Once you check it out here. Okay, so I write is here. So Newman projection formulas. Now first I'll write like this. So this is the second carbon atom and this is the first carbon atom. This is the first carbon atom. First carbon atom is attaches with the CH3, H and H. Okay. Second carbon atom also it is attaches with the methyl group and here H it is there, here H it is there. Okay. Now this we can call as the eclipsed form. This we can call as here eclipsed form. Eclipsed form is highly unstable. Eclipsed form is here highly unstable. Okay, sir, why it is highly unstable? Why the eclipsed form is highly unstable means here two bulky groups are present behind one behind another one. Okay, at the same time, same identical atoms are present one behind another one means here they have some repulsions. Identical atoms that comes close together means what happens? They have a repulsions or attractions. These identical charges are they comes close together means they have attractions or repulsions. Identical charges like plus plus. These plus plus are they comes close together means they have attractions or repulsions. Plus plus minus minus are simply if you see in the magnet, every magnet it is having the north pole and south pole. You know that one? Sirisha, is magnet is having north pole and south pole or not? Have you seen the magnet in physics?
Yes, sir.
Aditi, you? Have you seen the magnet or not? Aditi. Samita?
Yes, sir.
Have you seen the magnet? Magnet, ma. In lab, physics lab.
Yeah, sir.
Okay. If you observe that one, it has a north pole and south pole. Is there or not?
Yeah.
Okay. Sir, when two north poles are they comes close together, they have attractions or repulsions.
Sir, repulsion and when unlike poles come together, there is attraction.
Okay. So north pole, they are having the repulsions. North pole and south pole are they having attraction. So like charges are having repulsions, unlike charges are having attraction. Okay. So identical atoms are when they comes close together means they have a repulsion. While having the repulsion, they are highly unstable. To become as a stable, the rotating, we are rotating some 60 degrees. How much angle we are rotating here? We are rotating some 60 degrees. Whenever you are rotating 160 degrees means, okay, so first carbon atom we are keeping as a constant. I'm not disturbing the first carbon. CH3, H, H it is there. When the second carbon atom rotates some 60 degrees means this methyl group it comes here. Okay, this methyl group comes here. And hydrogen is comes here. And this hydrogen is it moves from here. Okay, so this we can call as a skew or Gachi form. This we can call as a skew or Gachi form. Okay, and again, if you rotate one more 60 degrees, 60 plus 60 total, how much it is, ma? 120 degrees. Okay, again also I am rotating only 60 degrees only. Okay, again also I am rotating as here 60 degrees. So 60 plus 60 total from here to here means you will get as a 120. Okay, if you rotate for this structure only, if you rotate 120 degrees means again you will get as one more structure. Okay, so what is the another structure you will get as means here? In this one, first carbon is we are keeping as a constant. Here CH3 is there, here H and here H. So this methyl group is moves to here. Okay, I'm writing as from here. And this hydrogen is moves to here. then I'll write as a hydrogen. And this hydrogen is moves here. Okay, now we got as a one more structure. In this one, which one are they comes close together means hydrogen, hydrogen. Okay, hydrogen, hydrogen, identical atoms. So that means when the identical atoms are comes close together, means they are also having light repulsions. Partial repulsions are there. And whatever the structure we got, that we can call as a partially eclipsed form. Okay, what is the structure we got as here? That we can call as a partially eclipsed form. Partially eclipsed form. Again, this one also if you rotate one more 60 degrees. Okay, if you rotate one more 60 degrees means total rotation, how much we are rotating means 180 degrees. If you rotate total 180 degrees means two methyl groups are present exactly opposite. Okay, so here one methyl group is actually, here also one hydrogen is there, here hydrogen it is there. And if you rotate this methyl group, okay, if you rotate with this methyl group, it comes to the center, exactly opposite CH3. Here H it is there, here H it is there. So whatever, whenever they are present exactly opposite direction, that we can call as a anti-staggered. Anti-staggered we can call. Okay, so anti-staggered one is more stable form. Sir, why the anti-staggered form is more stable means identical atoms are present exactly opposite. Our bulky groups are present exactly opposite. When the bulky groups are exactly present in opposite direction means they become as a more stable. Now you got the clarity? Okay. Right, sir. So we can rotate 360 degrees angle. We can rotate 360 degrees angle. Again, if you rotate one more 60 degrees means, again if you rotate one more 60 degrees means 270 means you will get as a partially eclipsed form. Okay, 260 degrees angle means again you will get as a partially eclipsed form. Again, if you rotate one more 60 degrees means, okay, sorry, it is 240. 240 na 180 plus 60 ma 180 plus 60 is here 240. Okay, 180 plus 60 is here 240. So by rotating the 240 degrees you will get as a partially eclipsed form. Again for one more 60 degrees, that means total you will get as 240 plus 60, how much you will get ma? So here you will get as a 300 degrees. By rotating of the 300 degrees angle, again you will get as a skew or Gachi form. Okay, again you will get as a skew or Gachi form. Again, if you rotate one more 60 degrees means for 360 degrees, again you will get as a eclipsed formation. Okay, so based on that one, once you check it out the angles, sir, eclipsed form is obtained at 0 degrees and 360 degrees. When the eclipsed form is obtained here, eclipsed form is obtained at 0 degrees and 360. And skew form is obtained at what angle we are getting as a skew or Gachi form? Aditi, Samhita, at what angle we are getting as a skew or Gachi form? One is the 60, another one is by rotating 300 degrees, we will get as a skew or Gachi form. And partially eclipsed form is obtained at 120 degrees and 240 degrees. 120 degrees and 240 degrees. So anti-staggered form is obtained exactly at 180 degrees angle only. Anti-staggered one is obtained exactly at 180 degrees only. Okay. Now, sometimes they are asking the stability order. What is the stability order of the N-butane? Stability order of N-butane. Stability order. Which one is more stable? Which one is more stable? Any one of you? Already you had seen the rotations. Clearly I explained. Which one is more stable? Sirisha? Which one is more stable in the core structures? Either eclipsed form, skew or Gachi form, partially eclipsed or anti-staggered. Samhita, which one is more stable? Sirisha giving answer. Samhita.
Anti-staggered.
Very good, ma. So which one is more stable means here anti-staggered. Okay. Next, Samhita, which one is more stable after the anti-staggered?
Partially eclipsed.
No, ma. Let us see. Partially eclipsed means two atoms are one is behind another one. Na? They have a repulsion, slight repulsions are there. If
Okay,
you
then
compare
skew
this
or
one and this one,
skewer.
skew and Gachi form is more stable because of two atoms they are not near, so one is behind, not one atom is not behind another one here. Okay, they have a some angle. Okay, so that's why they have a less repulsion. So according to that one, which one is becomes as a more stable means skew form is more stable. Then next, Samita, which one is more stable? Next,
Then
partially.
partially eclipsed. And then eclipsed highly unstable.
Okay, partially eclipse. Okay, partially eclipse. So least stable is eclipsed form is least stable. Least stable is eclipsed form is the least stable. Okay, to make you confused, can I give one question? Okay, so one question mark. Now, my question is all of you. So everything now you understood until here. All of you, anyone having doubts? First, you give me the clarity. Sirisha, Samhita, Aditi, Sai Akshit. Do you have any doubt until here?
No doubt, sir.
No doubt. Now I'm giving one question mark. Okay. So what is the question means?
Sir, could you
So,
once scroll up?
ma?
Roll up, sir.
Okay.
So could you once scroll up again?
Little bit, ma.
Yes, sir, more.
I will forward. I am forwarding the PDF. I am converting the PDF and updating in the app also. I don't know. Are you observing the notes or not?
Okay, sir. That's okay.
Then, ma.
Yes, sir.
Can I scroll down? Okay. Right. Let's see. My question is here 1 comma 2 dichloroethane. 1 comma 2 dichloroethane. First question is 1 comma 2 dichloroethane is exhibits. Okay. 1 comma 2 dichloroethane is exhibits conformational isomerism or not. 1 comma 2 dichloroethane is exhibit as a conformational isomerism or not. But now only I told, starting only I told, alkanes are exhibit as a conformational isomerism. Alkanes are exhibit
Sir,
as
it
a
does exhibit.
it exhibit as a conformational isomerism, Aditi.
Yes, sir, that's what I said. It does exhibit confirmation.
Yes, it exhibit as a conformational isomerism. Now, Aditi, my question is in 1 comma 2 dichloroethane, which form is more stable? Because of we are getting as some different structures. Na? What are the structures we are getting?
180 degree. So the 180-degree one, because opposite charges, it will be more stable.
Very good, ma. Okay, so if you take 1 comma 2 dichloroethane, okay, if you rotate 180 degrees, 180 degrees if you rotate means which form you will get as staggered formation. Okay, you will get as a staggered formation. Okay, staggered formation is more stable. What is the stable one? In 1 comma 2 dichloroethane means here staggered form is more stable. Okay, now little bit JEE question mark. Slightly I'm modifying. Okay, slightly I'm modifying here. So what is another example means here? So for this one, you want any structure? Any one of you?
No, sir.
Okay, then I'll give one more structure. My question is ethane 1 comma 2 dipole. Ethane 1 comma 2 diol 1. Ethane 1 comma 2 diol. What is the stable form in one? What is the stable conformer of ethane 1 comma 2 dipole? That is my question. Options: eclipsed form, partially eclipsed, skew or touchy, anti-staggered. 1 comma 2 diol. If you want a structure, please select the structure clearly. CH2 bond OH bond CH2 bond OH. So this is the structure.
So what are the options?
4 only, ma'am. We have 4 conformers only. Eclipsed form,
Staggered?
ma'am.
Will it be staggered?
It is not the staggered. So this is the exception case. Let us see, Aditi. So you tried very well, Aditi. Okay, actually we can expect as a staggered form is more stable. Okay, so because of two OH groups are, it has to be present at opposite direction. But in this one, which one is
Will it
more
be
stable?
will it be partially eclipsed because O and O will have lone pairs?
No, ma. Actually, in this one, we'll get as a skew form is more stable. Skew form is more stable. Sir, why you are getting as a skew form is more stable means we have an intramolecular hydrogen bond. Okay, so what is with the hydrogen bond? Any one of you? Any one of you having idea about the hydrogen bonding?
No, sir, we don't have the lesson hydrogen.
Amma, is that Aditi is there? Chemical bonding chapter it is there. In chemical bonding chapter, we are studying about the types of the bonds. Ionic bond, covalent bond, coordination covalent bond,
So there was
hydrogen
a very
bonds.
little part of that. Like they said they will teach in hydrogen chapter, but then they deleted it.
No, it is very important concept, Aditi. Because of same concept, all organic chemistry is going to be repeated. Because physical properties and all, we are going to be explained based on that concept only, Aditi. Okay, sir, Aditi, what is meant by the hydrogen bond means? Sir, the electrostatic attraction forces present in between highly electronegative atom and positively charged hydrogen is called as a hydrogen bond. Sir, what are the electronegative atoms we are taking means? Only nitrogen, oxygen, fluorine. Okay, so which elements are involved in the hydrogen bonding means here? Only nitrogen, oxygen and fluorine are involved in a hydrogen bond. Okay, now due to the presence of the hydrogen bond is classified into two types. One is intramolecular hydrogen bonding, another one is intermolecular hydrogen bonding. Sir, what is meant by the intramolecular hydrogen bonding means if the hydrogen bond is formed within a molecule means that we can call it as a intramolecular. Intramolecular. If the hydrogen bond is formed in between two different molecules, means that we can call it as a intermolecular hydrogen bonding. So in this condition, which one is more stable means here skew form is more stable. Why it is more stable means due to the presence of the intramolecular hydrogen bonding. It is JEE type of question. It is JEE level question. Now all of you understood? Aditi? Sirisha, do you understood or not?
Yes, sir.
Okay. Samhita, do you understand or not?
Yes, sir.
Aditi, now you got clarity. Sai Akshit. Okay, right, I think so. We are having next class. Hope so Sir is waiting for you. Okay. So tomorrow we'll do some of the examples based on this one. Okay. So now we finish the concepts of the conformational isomerism. We'll continue in the next class. Thank you all.
Thank you, sir.